Hello guys, welcome to Tough Math, a YouTube channel that features solutions to some math competition problems given in the past several years here and abroad. Our problem for today is this. Let S be the sum of the greatest integer values of the square root of k, where k runs from 1 to 2024. Then find the greatest integer value of S. Okay, so first, we take note of the fact that 2024 is equal to 45 squared minus 1. And then for any real number x, positive real number x, the greatest integer value of the square root of x is equal to k if and only if k squared is less than or equal to x, but x is less than or equal to k plus 1 squared minus 1, which is equal to k squared plus 2k. Also, there are 2k plus 1 integers x such that the greatest integer value of the square root of x is equal to k. Okay. So from this observation, we make the following table. First column is the range of the x's. So we have 1 is less than or equal to x, less than or equal to 3. And then we have 4 less than or equal to x, less than or equal to 8, because the next square integer is 9. So we exclude 9, and then we have 9 here, less than or equal to, the next square integer is 16, but we stop at 15. And then we have x is between 16 and 24, which is 1 less than the next square, which is 25. Okay. Then the next column of this table is n. Let's put it, or let's call it k. So we have k, and it is equal to the greatest integer value of the square root of x. And for all these numbers between 1 and 3, first row, first column, the value of k is 1. In the second row, the value of k is 2. In the next row, you have 3. In the next, you have 4. Okay. Now, the next column is the number of integers having that greatest integer value. So we have 2k plus 1. We have mentioned that above there are 2k plus 1 integers x such that the greatest integer value of the square root of x is equal to k. So here the integers are 1, 2, and 3. So there are 3. And then here the integers are 4, 5, 6, 7, 8. So there are 5. And so on. They are all odd numbers. This is 9 here. And then here we have x between 25 and the next square number is 36. So we are up to 35 only. And there are 5. The greatest integer value of the square root of x is 5. And there are 11 of them. So the sum of k is equal to k times 2k plus 1. So in the first row, we have 1 times 3. So we have 3. In the second row, you have 2 times 5, which is 10. In the third row, you have 3 times 7, which is 21. In the fourth row, you have 4 times 9, which is 36. And then we have 5 times 11, which is 55, and so on. Okay. And if we continue, then we have 43 squared less than or equal to x less than or equal to 44 squared minus 1, whatever that is. And then we have x less than or equal to 45 squared minus 1, which is equal to 2024. Okay, so this one is 44 squared. And what will these numbers be? This one would be 43. This one would be 44. Okay. And then this number would be 87. here. And this number would be 89. And this number here would be 43 times 87, which is equal to 3,741. And this number here would be 44 times 89, which is equal to 3,916. Take note or remember that K here is equal to the greatest integer value of the square root of x. So let's not forget that. Therefore, therefore S would be, which is the sum of the greatest integer value of the square root of k from k equals 1 to 2024. This would be equal to n times 2n plus 1 from n equals 1 to 44. Okay? And this is equal to the sum of 2n squared plus n from n equals 1 to 44 which is equal to the two sums. Okay, let's break this down into two sums. This is 2 times n squared from 1 to 44 plus the sum of n from 1 to 44. So this is equal to 2 times, we have 44 times 45 times 89 all over 6. Sorry, it's not equal but plus, so this one is plus 44 times 45 divided by 2 following the formula, and so we have 58,740, and then we add to it 990, which gives us 59,730. Okay. Now, uh, 244 squared is equal to 59,536, and our S is this number, which is less than 245 squared, which is equal to 60,025. Therefore, the greatest integer value of the square root of S is equal to 245. 44. Okay, so this is our answer. The greatest integer value of the square root of s. Sorry, I forgot to write the square root of s here. There should be a square root there. Okay. And then the challenge is evaluate s. This time s is defined differently. It is the sum of the greatest integer value of 65k over 107, where k ranges from 1 to 106. So challenge yourself to solve this problem before watching the next video, which will feature its solution. And also, I would like to add this something to think about. Every problem carries with it the seed of its own solution, the seed of its own solution. This is a statement which is full of hope, because it says that every problem carries with it the seed of its own solution. However, I failed to get the name of the one who said this, so I will just call him unknown. So that's it for now. I hope you enjoyed our discussion, you learned something from it. So goodbye for now, and may God bless you all.